Welcome back. This is the second part of the half angle formula related problems. This is problem type 2. Suppose we are given cosecant alpha equals to root 10 and alpha in between 90 degrees to 180 degree. If this is the condition, we have to find the exact value of sine alpha by 2 and tan alpha by 2. So first of all, we look at the condition here. We're given our alpha is in the quadrant 2, so we can draw a coordinate system. We can draw a coordinate system, x-axis 0, y-axis. Since alpha is in quadrant 2, we can draw a right angle triangle like here. So we're also given cosecant alpha equals to radical 10, which can be written as radical 10 over 1. So if we relate this with this triangle right here, we can write y equals to 1 and r equals to radical 10. So now we have to find out this x using the Pythagorean theorem. We can calculate x like this. So x squared plus 1 squared equals to radical 10 whole squared equals to simply 10. So x squared equals to 10 minus 1 equals to 9. And then x equals to negative square root of 9 equals to negative 3. Note here, this x is negative because our alpha here, our alpha is in quadrant 2 and x is in the negative direction, so it should be negative, must be negative. So out of this triangle, we can find the value of cosine alpha. Cosine alpha equals to x over r, which is negative 3 over square root 10, and sine alpha equals to y over r equals to 1 over square root of 10. So normally we don't like any irrational number as a denominator, but for now we can leave our cosine alpha and sine alpha like this. When we finalize our answer, we can simplify that later. So now look at the problem here. Look at the condition, this condition one more time. We are given here alpha satisfies this 90 degree, which is alpha is greater than 90 degree and less than 180 degree. Now if we divide each of this quantity by 2, we get 45 degree, which is less than alpha over 2, alpha by 2, and this alpha by 2 is less than 90 degree. That means in our quadrant system, this is 45 degree. For let's say this is 45, and our alpha by 2, it is between 45 degree and 90 degree. So our alpha by 2 should be somewhere here. This is alpha by 2. Okay, so since the angle, this is in quadrant 1, so the formula for sine alpha by 2 will take the positive part. So sine alpha by 2 equals to 1 minus cosine alpha over all over 2 square root. We already calculated the value of cosine alpha, that is negative 3 over root 10. So Now we just have to substitute those values here. So 1 minus root 3 over root 10 all over 2. This equals to, we can rewrite this 1 as a ratio of root 10 over root 10. The purpose of writing this way, we want to make common denominator. And then this minus and minus plus 3 over root 10 all the way all over 2. So here is our expression. Now we have to simplify the final expression here. So we can rewrite that as root 10 plus 3 times 1/2, and then finally we can leave our answer like this: root 10 plus 3 all over 2 root 10 and square root everything. Hope this helps. Now we'll solve one more problem. No, we are not done yet. We have to find the value of tan alpha by 2. And tan alpha by 2 equals to, we can use this formula, sine alpha over 1 plus cosine alpha. And now we just have to substitute the values of cosine alpha and sine alpha. We calculated sine alpha equals to 1 over root 10 here, and cosine alpha, we already used that value. So let's substitute those values here. So sine alpha, 1 over root 10 all over 1 plus negative 3 over root 10, and then we get 1 over root 10, 1 minus 3 over root 10. We can rewrite this 1 to make common denominator. So let me write that: root 10 over root 10. So in the numerator we have 1 over root 10, and in the denominator we have root 10 minus 3 over root 10, and then we can cancel out this root 10 both from the numerator and denominator, and then we are left with 1 over root 10 minus 3, and then we can leave our answer like this. And also we can simplify this expression by multiplying both the numerator and denominator by the conjugate of the denominator, meaning we can write 1 times root 10 plus 3 all over root 10 minus 3 times root 10 plus 3. So we just multiplied in the numerator an extra term, and to cancel that extra term we divided by the same term. Okay, then if we use the FOIL rule, in the denominator we'll have 10 minus 9, and the numerator will have root 10 plus 3, and our final expression, this is the simplest form of our answer. We cannot simplify it furthermore, we can, since we have to find the exact value. So that's the end of the first problem. We can solve one more problem. Let's say let's say problem 2. Let's say we are given cosecant theta equals to negative root 5 over 2, and our theta lies in quadrant 4, that is 3 pi by 2 is less than theta, and theta is less than 2 pi. And find sine theta by 2 and tan theta by 2. It's kind of same problem, but different parameters, different values. So since theta is in quadrant 3, quadrant 4, we can draw our angle in coordinate system. This is the x-axis, y-axis, origin. Let's say this is our angle. So this is theta. We can draw a right angle triangle, and then our y equals to -2 and r equals to square root of 5, and we don't know the x. We can find this x using the Pythagorean theorem. Uh, Using Pythagorean theorem, we can write x squared plus -2 squared equals to square root of 5 whole squared. Then x squared plus 4 equals to 5, and then x squared equals to 5 minus 4, 1, and then x equals to positive square root of 1. This is positive because it's in the first quadrant, it's in the positive direction of the x-axis. So x equals to 1, we just got. Now from this triangle, we can find the value of sine theta and cosine theta. So sine theta is the ratio of y over r equals to -2 over root 5, and cosine theta equals to x over r equals to 1 over root 5. Again, we're leaving our sine theta and cosine theta value in this irrational format just because we'll finalize this expression in our final answer. So for now, we're leaving the values like this. Now, uh, we have to consider the condition again. I mean, this condition again. So here, 3 pi by 2, which is less than theta, and theta is less than 2 pi. Now, if we divide everything by 2, we get 3 pi over 4, which is less than theta by 2, and theta by 2 is less than pi. Now let's see where this angle theta by 2 lies. If we draw a straight line right here, this is 1 pi by 2, and the y-axis, if I start moving from here and I come all the way to y-axis, this is 2 pi by this is pi by 4, this is 2 pi by 4, that means 90 degree, pi by 2. If I draw one more straight line right here, this is 3 pi over 4, and the x-axis, the negative direction of x-axis, this is 4 pi over 4, which is actually pi. Now this inequality here, it indicates that our theta by 2 is in between 3 pi over 4 and pi. That means our pi by 2 angle is not sorry our theta by 2 angle is right here. This is theta by 2. Okay, so the theta by 2 angle is in quadrant 2, therefore sine is positive in quadrant 2, and we will use these formulas for sine theta by 2 equals to positive formula 1 minus cosine theta all over 2, and then we have to plug the value of cosine theta that we already calculated here. So 1 minus 1 over root 5 all over 2 square root. And then we just have to simplify. Square root of 5 over square root of 5 minus 1 over square root 5 all over 2 and then we can write square root 5 minus 1 times 1 over 2 square root, and our final expression will be square root 5 minus 1 over 2 root 5 all square root. And that's the end of the first part. Now we have to find the value of tan theta by 2. So tan theta by 2 equals to sine theta over 1 plus cosine theta. We have already calculated the value of sine theta, which is negative root 2 over 5, negative 2 over root 5, negative 2 over root 5, and the value of cosine theta is negative, oh, I just messed up. The value of sine theta, no, it was alright. So sine theta is negative 2 over root 5 and cosine theta is 1 over root 5 positive. So negative 2 over root 5, and this is positive 1 over root 5, and then this is 2 over root 5 over root 5 over root 5 plus 1 over root 5 equals to negative 2 over root 5 root 5 root 5 plus 1. We can cancel this root 5. Then we are left with negative 2 over root 5 plus 1. We can leave our answer like this, or if we simplify, meaning if we multiply both the numerator and denominator by the conjugate of the denominator, we'll end up our final answer as 1 over 2 times root 5 minus 1, and that will be the exact answer. I hope this helps. Thank you for watching.